solar facility, and in this session, as Fernando has just introduced you, we will study the different steps for the execution and commissioning of a solar plant. In this session, we will start with the civil works, then we will go by the mechanical and electrical works in a solar plant, and the environmental issues. We will try to pay attention at the quality, where we will find the critical issues during the execution, and then the safety and labor risks. Finally, we will end with the commissioning and the key points. So let's start with the civil works and its infrastructure preparation. Talking about civil works, it's important to distinguish between two types of projects. First, the rooftop projects, where we will not find many civil works. Just the connection of the inverter and the meters, and maybe installing any safety devices for our workers. But then we have the ground projects, where the civil works are really important. For ground projects, the main civil works will be the terrain leveling, the accesses and inside paths, and then the trench opening for the cable installation. Let's study the three of them. We will start by the terrain leveling. A good design can help us to reduce this tax, saving a lot of money. But only the required works should be done. Some good practices would be selecting a flat terrain, selecting a structure type which doesn't need a concrete base, and then by the other side, the choice between a fixed or a sand tracking project can be determinant for the needs on this issue. So, as we have said, it is important to take our time during the project design in order to reduce this task. Talking about internal roads and paths, we must take into account that the roads or paths have to allow the circulation of trucks. Here we have a table with the required radius for different types of vehicles. We can find the two-axis simple truck or the trailer, which would be the vehicles most used in a solar plant. At the right of this table, you can find the minimum radius for external front wheel and the minimum radius for internal back wheel. We will see in the next slide how this influences to the path width. Anyway, we recommend to use already existing paths. Here you have a draft on the radius of a track. About the material to be used for these roads and paths, we can use gravel and river sand in the proportion that it's shown in this slide. Once the installation has been commissioned, the internal paths will not be used too much. To end with the civil works, we will talk about the trenches. Normally in a PV project, it is recommended to install all the cable buried underground, so that we can protect it against atmospheric conditions, vandalisms, and other problems that may cause damages to the cable. Also, a manhole should be placed every 40 meters or in any direction change, in order to ease the cable laying and just in case an incident may happen. Here we can find some typical examples of designs of the trenches in a PV project. In the next slide, we will study the trench distribution deeper. But a good advice would be considering using the same section in all the trenches. So, in this slide we have the composition of a typical trench. Normally, a trench will consist on a river sand base, then some space for the pipes where the cables will be placed inside, and then a backfill of sifted salt and soft sand containing a cable caution tape. If vehicles are supposed to pass by the area of where a trench is going to be set, then a concrete layer should be set at the top. With these civil trenches, we end with the civil works and we go towards the mechanical works. The main mechanical work to be done during the execution of a solar plant might be the panels and structure installation. We can find different types of structures depending on its usage and lifetime. Here you have a table with some types of structures and their main features. As we said during the first webinar, especially in rooftops, the structure can be set parallel to the surface where it is to be installed. That is called flat, or with the optimum tilt for each latitude. This is called tilted. In the table at the bottom of this slide, you can see the main features of a flat and a tilted structure. As we studied in the first webinar, the flat structure doesn't have any wind action and has a lower cost, as it takes profit of the slope of the roof. However, the tilted structure has a higher cost, but normally we can optimize the tilt to get the maximum production during the whole year. So we have to balance from our decision considering both the price and the performance of our plant. A critical issue during the structure installation is its anchoring to the ground or to the roof. In a ground type facilities, we have two possibilities. One, the ground anchoring system, and then the concrete basement system. For ground anchoring systems, the main advantages that we can find is that it is a structure it's quite easy to be dismounted, and that we can adapt the structure easily to the terrain orography. Normally, for this kind of structures, we use screws that have a length between 1 and 1.6 meters. However, this type of structure cannot be used in a rocky terrain. By the other side, the concrete basement structure will require a flat surface. It can also easily be dismounted, especially if we select this type of structure above the ground. For roof type facilities, we also have two different possibilities depending on the type of roof. We can choose from, we have two types of roof, We have metal roofs and tile roofs. Within the metal roofs, we have two different options. We can choose between anchoring our system directly to the purlins of the building, or we can use specially designed anchors that will be fixed directly to the roof setting. At the left of this slide, you have some diagrams on how the different types of anchoring systems would be. For tile roof, a typical solution would consist in using a U-shaped piece which is anchored directly to the roof. This way we can avoid drilling the tile, but we will have to move the tiles, and sometimes it could be dangerous because it can produce leaking. If we don't want to use this type of solution, there is a special piece that can go through the tile. The only problem of this kind of piece is that we can break the tile and also cause leaking. Anyway, for any of the solutions that we will take, we should consider the following aspects: the safety, the roof type, and the ceiling. In the safety, it is very important to install a lifeline or a skylight network if we consider the roof is not safe enough for working on it. If the roof type is asbestos type, then it might be dangerous installing an anchoring system. Sometimes it is recommended to change this type of roof to metal roofs. It is important to consider this during the project design and calculation, because it may be cracked by stepping on it, producing leaks, or it could even be broken, and this could be really risky for our workers. Finally, we have the ceiling, which is really important to avoid leaking. To end with this chapter, we must know that we should take into account the loads on the roof. Here, in this table, you can find the main loads that we will find in a PV project. We have considered the material weight by a square meter. These loads are really important to study the wind effect, where both the panel height and the exposed surface must be considered. We should also consider extra loads during the execution and the accesses, which should be distributed all along the roof surface. So, now we will study the electrical works. The main electrical works to be done during the project execution are: first, the module's electrical cabling; second, the earthing system; and then, third, the element connections cabling. Here we can find the module's electrical cabling. Normally, we will use cable included by the panel manufacturers when cabling the panel strings. This cable is normally composed of copper, and it's usually ended in fast connectors which help us to easily connect one panel to the other. It is important to confirm with the manufacturer that this cable is included in the supply. In rooftops, it is important to know that the cable canalization may be done under hot galvanized cable tray, which simplifies the mounting works and eases the maintenance tasks. For the indoor installation, a plastic tray may be enough. In ground installations, as the electrical works will be done into them, the cable must be designed for being used in trenches. It is really important to take time to design the cable trenches. We can optimize a lot the electrical works duration with a good design on the number of cables by pipeline, the extra space by pipeline, and the manholes placed locations. Some good practices could be marking the cable to avoid connection issues, and then avoiding corners of any elements which may cause any damage in the cable isolation. About the electrical cabinets, some considerations are very important to be taken. First, that a different IP may be required depending on the location of the cabinet. For outdoor installations, we should use at least IP65, whereas for indoor installations, an IP21 will be enough. Second, we have to consider that it is really important to pay attention at the element connections and the identification of each cable and component in the project documentation. Finally, we will have to verify the minimal required volume for the heat dissipation in our electrical cabinet. This chapter, the electrical works, will finish with the earthing system. The elements to be connected to Earth in a PV facility are the ones listed here: the PV panel frameworks, the structure, the metal cable tray, the metal elements in electrical cabinets, and finally the PV inverters. As we learned during webinar 1, for small facilities, the earthing system would be quite simple. Just 2 or 3 pegs will be enough depending on the soil resistivity. For bigger facilities, a cable grid should be installed. This cable grid must be calculated during design of the solar plant. During the next chapter, we will study the environmental issues during the project execution. Nowadays, we have a world context where the society is quite committed with environmental impacts. The ISO certification 4001 is a tool that allows us to take and to show to others our environmental commitment. Every solar power in the world should demonstrate the coherence with their ecological message by developing a good policy. In this slide, we can find the definitions that are set in the ISO 4001 to these different aspects: the environmental aspect, the environmental impact, and what is a residue. These definitions are important to know and to be taken into account during our project execution. To develop a good environmental management, we should: first, know the enforced legislation. Know the environmental aspects that concern our business. Evaluate the impact that has our activity on the environment. Propose indicators for the measured aspects and impacts and use them to develop new preventive and corrective measures. And it is really important to have an emergency plan for any incidents that may damage our environment. Then we should have a good management for the generated residues in our solar plant. During the next slides, we will find some charts that may help us developing our environmental management during the project execution. For example, here we have a list of aspects and impacts that can be found in a PV installation. We can see the different aspects and their impact into the environment. For instance, we can see in this table that a fire may cause atmospheric pollution and may also cause impact on the fauna and the flora. This kind of incidents might be extraordinary, whereas the electric energy consumption or the fuel consumptions may be normal incidents that happen in our solar plant. For each of these aspects, we should design an emergency classification in order to classify them and to consider how these aspects influence the environment. For example, here you can find the analysis to the fire aspect. We have to consider the probability and the seriousness, and using these ratios we will know the assessment. Normally this assessment is calculated by multiplying the probability by the seriousness of a concrete aspect. Here we can find the aspect classification for a lot of different aspects that we might find in a solar project. For example, we can see that in this table we have evaluated the frequency, the seriousness, the consequence, and finally we have got a ratio that we call the assessment. This assessment will be calculated by adding the seriousness and the consequence and then multiplying this number by the frequency. For example, for the noise generation, we can consider it as not very serious. We can decide that the consequence won't be very high, very tough, but the frequency is quite high. So if we add n plus 1 plus 1 and we multiplied this by 3, we have an assessment of 6. We can decide that this assessment is not significant for the development of our solar plant. Another very important point would be having an emergency plan for each incident that may happen in our facility. For instance, here we can find an example of the emergency plan in case of fire. In this emergency plan, we define the frequency, which is yearly, and then we define the practice description that should be done yearly, and we define which tasks should be done. But we also define which preventive measures we can take to prevent fire and what could be the actuation plan in case that fire happens. To end with the environmental issues, we will have a last example on the residue management process. It is important to know that we have to control the residues that are being produced during our activity and which is the quantity of each of them. Then we have to do the management of the residue according to its type. Here we can find a list of residues and considering which are normal urban residues and which are dangerous residues. There are many companies that help us to manage with the dangerous residues. So, once that we have finished with the environmental issues, we will review the critical issues during the execution to guarantee the quality of our PV project execution. The most critical aspects will be the materials and the work execution. The materials task, the list of the tasks that we should do to check the materials would be checking that we have received the goods that have been requested and that we have received all of them, doing an inspection of the goods at their arrival to check if there are possible material faults or defects, and then checking the electrical and mechanical parameters of each of the elements and materials in order to avoid early breakdowns of the elements in the solar plant. During the work execution, it is important doing a correct planning of the work so that we can avoid delays and dead times of our workers. It is really important to have an updated documentation for our work, and like this we could check that the worker has the latest edition of the information. Here you can find a diagram of the different tasks to guarantee the quality of our PV facility for both the material reception and the administration. It is important to do all of these tasks during the material reception and the material administration, and normally the work manager would supervise that these tasks are being done. During the material administration, it is important checking that the items indicated in the delivery notes correspond exactly with the ones that had been ordered. Then we have to check that there are no materials that haven't been sent, and in case there are any materials lacking, we should claim instantly for it. Finally, during the material administration, we have to check the payments that we have done for all the materials. When the material reception, we have to check that all the items that have arrived correspond to the items that we have ordered in the delivery note. Then we have to do a visual checking. During the following slides, we will study a little bit more on how to do this visual checking. And finally, we have to do the checking of the electrical and mechanical characteristics of every element. In this slide, we have some of the obligations and responsibilities that the work manager and the workers should consider in order to improve the quality of our PV facility. The work manager should fulfill the planning deadlines. He should also check the documentation that he is giving to the workers. Then he should check the quality in every intermediate milestone of the project. He should check the management of the residues that are being produced during the execution of the project, and he will do at the end of the work a final checking of the whole project. Whereas the workers should execute their works according to the work order from the manager. They should notify every incident that occurs during their works, and they should accomplish the working order that has been given to them by the manager. Until now, we have seen some of the measures to guarantee the quality that the workers and the managers have to take into account. But as we said, right now we are going to explain the different inspections we should do to the elements of the solar plant. We are going to use as an example the panel inspection, as it is the most expensive element in the installation. First of all, we should choose some samples on all the modules that we receive. It would be impossible checking all of the modules in our solar plant if it is already a big size plant. But once that we have done this selection, we should do a visual, an electrical, and a thermal supervision. For example, during the visual supervision, we can detect the frame defects, the glass defects, the connection box defects, and the cable and connector defects. We should do this kind of inspection also with the rest of the elements in our PV facility. To end with the quality chapter, we have included a slide to explain the thermal inspection of the modules, as it is a simple method that detects the faults in the solar panels. The checking of the installation is developed in a rapid and visual form, with a special tool that shows us any defect in the module, as you can see in the pictures that are being showed in this slide. With this special kind of camera, the color of the modules might change depending if there is any hot spot in the panels, and this may indicate that there is a defect in this panel. As you can see in the image at the bottom at the right of the slide, there is some cells that has been highlighted in red. These cells should be checked as they may be defectuous. Here we have finished with the quality chapter, and we are going to talk about the safety and labor risks. It is very important to know that within every company it is obligatory to have a labor risk evaluation plan. Even the subcontracted companies should have their labor risk evaluation plan adapted to our activity. And we have to consider, in order to do this, we have to study the particularities of our activities, and then we will have to analyze the risk of each of the activities that we will develop in order to take actions depending on each risk. For example, here we can see a small analysis of the risk of a solar company activities that will continue also in the next slide. Here, for the different activities, we have some of the main risks that we will try to handle with. For a PV installation on the roof of a building, some of the hardest risk would be the fact that we are working at great heights, and then the point that there are different types and tilts of roofs, and we can cause leakings, or as we have already said, the roof can break, and that may cause a risk to our laborers. In a PV on the ground for both fixed and sun tracking systems, it might be risky working with a larger number of workers so that we cannot control all of them. Also, we will probably have to use cranes, and this can be risky. In this slide that we are showing you now, we have other activities and risk for both the roof facilities and the ground facilities. It is important to mention that in ground facilities there is a big electrocution risk, which is bigger than the roof facilities, as the installed power will normally be bigger in this kind of installation. Once activity analysis has been done, we should do a summary to know and evaluate the risks of every job inside our activity, and also to train our staff on the risks which depend on their job or workstation. We should distribute the protections for all the equipment adapted to every workstation, and it is really important to designate a person who will be in charge of checking the correct execution of the prevention plans. Finally, it is very important, as we have said all along this webinar, to develop an emergency and evacuation plan. Now we have got to the final chapter of this webinar, which is the commissioning tests and their key points. Here we have a diagram of the whole project. We can see which tasks are to be done during the different stages of a project. In the first webinar we studied the project design, where the plans, the engineering, the technical data sheets, and the equipment manuals should be considered. Also, in case of sun tracking facilities, we should take into account for sure the sun tracker manual. Then, during this webinar, we have gone through the execution, where the project modification and the done inspections and the element identification should be taken into account. For this step that we are seeing and studying right now, which is the commissioning, it is really important to have a commissioning checklist and to check the production of the plant, the production of the generator, and the production of the inverter separately. Finally, in the next webinar, we will study the operation and maintenance. So we will not go through these different measures till we get to the next webinar. The main aim of the plant production checking is to maximize the productive capacity of the photovoltaic solar plant. Normally, these tests should be repeated at least every 3 years, but depending on the size of our facility, it might be done more frequently. To do this plant production checking, we can measure the plant performance by the instantaneous response to the cell temperature and the irradiance. Like doing this, we will evaluate the power at the plant output using the measures that we can get from the meter, and then we will have to evaluate also the global and direct irradiance in a calibrated cell. And finally, we have to have the cell temperature. It is important to use a calibrated cell from the same technology that we are using in our panels in order to have a good measure. In this slide, you can see the main elements that would be used to do the checking of the plant production. Here you have in the image in the left, you have a meteorological station. This is used to get the temperature and the irradiance. Then, from the meter that should be installed in order to measure the energy that is being injected in the grid, we can get the power. With this data, we can estimate the plant production and check if it is within the ranges that should be the best ranges. If not, we can optimize the inverters or maybe check the different rows of the panels in order to improve this performance. It is important, or it might help us, if the meter has a communication port so that we can monitorize the energy that is being produced from a control area. In this slide, we can find the conditions under which the test for the plant production checking should be done. First, we should be measuring at least during 5 consecutive days from dawn to dusk. During these days, in the total of them, we should get at least 12 hours with a minimal period of irradiance over 600 watts per square meter. The periodicity of this measure should be every 10 minutes. Once that we have already got all these measures, we should compare them to the expected ones that we have got from the solar radiation maps that we have seen during the webinar 1, or from our meteorological station, in case that we have decided during the project design to install a meteorological station in order to measure the radiance and the temperature in the location where the plant will be set. Then we have to test the PV generator electrical characteristics in order to determine the electrical characteristics under the standard metering conditions defined by irradiance, which is 1000 watts per square meter for standard conditions, and by the cell temperature, which is 25 degrees for the standard conditions. We can obtain the curve from the generator and the one from a standard module, and we should compare both of them under the conditions that have been mentioned above. Nowadays, there are a lot of equipments that may help us to obtain this curve and to move it into the standard conditions. These tests have to be done 2 hours before and after the local midday, and the global irradiance has to be over 700 watts per square meter. Finally, we should also test the inverter electrical characteristics. This is the second most important element in our PV facility, and the main objective would be determining the characteristics which define the performance of the inverter. As we learned, during the first webinar, the main characteristics of an inverter would be the efficiency and the maximum power point tracking. We saw during the first webinar that the efficiency is defined by one side from the manufacturer, but there is also what we call the European efficiency of the inverter, which is a ponderation of the inverters depending on the load in the DC side. It is very important to verify that our inverter is working in the maximum power point, because like this we can obtain the maximum production from the modules in our PV facility. So, thank you for attending to this second webinar, and we will try, please send us your questions and we will try to answer some of them during this time that we have. Fernando, I give you the speaker.
Okay, very well. So thank you, Javier, for this session. So we are going now to change the settings, and let's try to go across some questions. So as general announcements, you are asking about the possibility to download the presentation. So it's available in the links presented here. So you can go there and find the slides, and you will also find the recording of the webinar today. So let's now go across some questions. So let me put the button here and make it bigger. Okay, so we will go for, let's say, 10 minutes in this Q&A. Okay, so let's start. One moment, please. There is a first question on the cost breakdown of typical installation. Are we going to talk about this, Javier, in the coming sessions, or we can go across this question? Thank you. Yes, Javier, you should activate your microphone. Thank you.
Yes, Fernando. Sorry.
Yep. Yep.
Wait a second. Excuse me. I think you are referring to the question from Jim that appears in
Yes.
my because okay. Well.
Q&A poll. Yes. Yes.
Okay. Well, this is a generic question. He's asking for the bill of materials and the cost breakdown for a typical 10 kilowatt PV solar array. We can maybe, well, this is we can maybe try to do the breakdown in some next sessions, but more or less we can estimate nowadays that depending on which country we are talking about, the cost per kilowatt peak should be around 3.4 euros per kilowatt peak. So this is the cost that can be more or less considered in depending on each country. Uh, I think that maybe during another webinar we could talk about the breakdown for the different elements in a solar facility. Anyway, well, we can give an average price, but we cannot give a concrete price, a certain price, as it might depend on each country in the world.
Okay. Thank you very much. So, one moment, please. We are selecting other question. Well, there is another question about wind load. So, what can you tell us about estimation of wind loads in photovoltaic installation? Thank you.
Here, to this question, what we could answer is that sorry, I think we have some problems with the audio. No, it's okay. Okay.
No,
Uh,
that's okay.
okay, I was hearing myself, but what we could answer is that mm, uh, well, to calculate the wind load, we should do a concrete study, and these kind of studies are usually done by an engineering cabinet for each case, depending on the wind um, speed, and as this person is asking, the height and the width of the structure. For rooftop installations, in flat installations, it is easier to be studied, but in this type of structures we cannot give an answer so fast, because it also depends in the legislation of each country. Anyway, if this person is interested, he could probably send us an email, and maybe we can ask him a little bit with more information on this, because it's not a like easily responded question.
Okay, thank you, Javier. So next question, for high temperatures like Greece, I think it's quite the same case in some places in Spain. So you have some experience on this. What should we do? Thank you.
Yes, there are many places in the world where the temperatures are quite well, a thing to be considered. As we said during the first webinar, In these cases, normally what has to be considered is using thin film modules, as these kind of modules have a better ratio and they have less system losses with the temperature. If we remember that what we studied during the first webinar, the crystalline modules have worse performance with the temperature. So a good practice would be selecting thin film modules, but then it is important to consider that the efficiency of these thin film modules is lower than the crystalline modules, so we will need a larger surface. But in case that we don't have any problems on the surface, it will be better selecting the thin film modules.
Okay, thank you. So another question on testing the inverter using a small load on the DC side. If you can maybe repeat the explanations. Thank you.
I'm going to go back to the slide.
Yes, one moment. Let me.
Well, in fact, I don't understand very well this question, because I don't see where we said that we can test the inverter by using a small load. I think these kind of practices depend on each type of inverter, and normally this kind of test. Wait a second, Fernando, please.
Okay.
Normally, this kind of tests. Well, sorry, I continue with the explanation. Normally, this kind of tests are defined by each manufacturer, as what we have said is that the European efficiency of the inverter will be given by the inverter manufacturer. This European efficiency defines for the different DC loads the efficiency that the inverter should have. So it is true that even if we haven't said it, we can check and we can test if the efficiency that we are obtaining from the inverter is the one that we would have by considering different DC loads and then measuring the efficiency of the inverter and checking if it is the same that is specified by the European efficiency of the inverter's manufacturer.
Okay, very well. So Javier, if you have identified any other question, you can go ahead. Otherwise, I will be sending any other question as you wish.
Yeah, the problem is that questions are moving.
What about, yeah, let's maybe go to
Okay.
thermography question.
Yeah, perfect.
So what can you tell us about this? Thank you.
Yes. Well, the thermography is quite an easy thing to be tested. The only point is that we need a tool, which is a concrete tool that might be, depending on the quality of this tool, it could be even quite an expensive tool. But the truth is that if our project is it's of a big size, of if we are planning to do several projects, it might be really worthy to obtain one of these tools to get the thermography. If we go back, I don't know, Fernando, if we can get back to the slide that it showed the picture for thermography for this thermal test to the panels. But if we go back to this slide, we can see that using this kind of tool, we will have an image similar. Yeah, here we have it, similar to the one that we can find at the right at the image in the right of the slide. So it's quite easy to determine that those cells that are being colored in red, they have problems, and they should be checked by the manufacturer or by any specialized company. Anyway, if our project is smaller, there are specialized companies, maybe installation companies, or companies which can be which can do for us this kind of tests to the modules that are being received. So that might be also a good practice if we want to check the thermography of the panels, sending them or subcontracting a company specialized in this.
Okay, very well. So maybe we can go for another question about the monitoring systems for PV installations. Is that something that we are going to
Yes.
see in coming webinars?
Yes, we are going to, well, in the next webinars we will study the different systems in order to do the monitoring of the PV facilities, and also to, well, to control the security in our facility. So to answer this question, yes, we are going to give more information about these monitoring systems, and we can say that they are really used, because they are the only tool that we have to check that the installation is producing what it should produce. So yeah, nowadays, well, at the beginning of the solar energy, we couldn't have this information in real time, but nowadays there are a lot of systems that allow us to have the information in real time. So they are very used all along the world.
Okay, very well. So we have another question, and we are probably going to adjourn soon. What is better for a 100 kilowatt solar project, and installing inverters of 5 kilowatts, or just one single central inverter of 100?
Yes, well, as we said during the yes, as we said during the first webinar, where we studied how to choose from the different inverters that we can find in the market, we said that it depends on the number of stages of the inverter. Here it happens more or less the same. We can choose installing various inverters or just having one central inverter. The points are that normally a central inverter might be cheaper than having, like for example in this case, 20 inverters of 5 kilowatts. But the advantage of having various inverters is that in case that one of them fails, we are not losing the production. In this case, if one of these inverters fails, we will be losing only 5 kilowatts from the 100 kilowatts. So we will be losing only a 5% of the production. Whereas if we have only a central inverter and it fails, we will be losing the whole production of our system. Here, in our experience, we have had quite a good experience by using a large number of inverters instead of using only one central inverter. But this might be considered for every project, considering the price and the production losses that we want to risk.
Okay, very well.
Also,
So,
sorry, Fernando.
thank you very much. Yep.
No, because it's also important that if we want to have replacements in situ in the solar plant, it might be easier to have a replacement for a smaller inverter like 5 kilowatts than having a replacement for an inverter of 100 kilowatts. Spare parts, yeah.
Okay, very well. So now we are going to adjourn here. thank you very much, Javier, for your second presentation. It was very clear and comprehensive. We we will leave these codes open if you want further uh, chat or interact with other participants. So I let you codes bigger, and it will be open for some time in order to allow you to interact. You will receive a newsletter where you will be notified about the links for downloading the presentation, for watching the recording, and also to some practice information about social media in order to interact. So thank you very much. Next week for the third lesson. Javier, if you want to adjourn, thank you very much.
Sorry, Fernando. I heard that you said something and you said my name, but I didn't understand. I didn't understand what you said. Sorry, can you repeat, please?
Just you want to say goodbye to our audience
Okay. Yes.
and then the session. Thank you.
Okay. Well, thank you very much to everybody for attending this webinar. If you have any questions or doubts, just write them in the chat or send them to to Fernando or to the system, and we will try to answer some of the questions, the main questions that we can find, and send you all the answers. So thank you very much, and we will meet next Tuesday for the webinar number 3.